Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm your host today. My name is Whitney Lee. I'm a developer advocate at VMware Tanzu. So each week we bring new presenters to showcase the work of cloud native technologies. We'll build things, we'll break things, and we'll answer your questions. So this week we have Neeraj Palecha here with us to talk about finding infrastructure as code missteps. But just a reminder, this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct, which basically just means be kind to everyone. Be kind to neither to me, be kind to your fellow folks in chat. But please do, if you're in chat, please do say hi and where you're from. I love that we're a part of a global community. I think it's the coolest thing. So during the presentation today, if you have questions, please put them in chat and we'll try to answer them as we go. All right, and with that, I'm going to hand it over to Neeraj. Neeraj, introduce yourself, please.
Thank you, Whitney. Hi,
Yeah.
everyone. I'm Neeraj Palecha. I I'm going to talk about finding missteps in your infrastructure as code. It's going to be a combination of best practices and things that I've gathered over the years, you should be using, practices you should be avoiding, and practices you should be adopting. So, about me, I've been working as a DevOps engineer for 4 or even 5 years now. Also worked as a backend engineer, um, and I've worked in teams of small size, which cater to 20, 30 people in an engineering team, and even to a larger DevOps engineering team, which manages platform and DevOps infrastructure, cloud infrastructure for 100 plus engineers.
Wow.
So, yeah, mostly planning to present what I've learned so far, and yeah, it's going to have code examples. We'll work through Terraform, different Terraform examples that I have today,
Awesome.
and yeah. So I have a poll, right? So if I think, yeah, mostly, so for Santosh in chat, right? It's mostly going to be about Terraform. I do have a Slido poll here. If people could maybe join using this QR code or this link, I have a few questions I would like to ask the audience, and just to get to know the audience better, and maybe tailor what I am going to talk about a bit based on the responses. So yeah,
So I went to the link. I don't see any questions right now at the link.
cool. So what I'll do is I'll enable the first question, and
Okay.
yeah. So the first question is about, do you actively work on cloud infrastructure, and is that your primary role, right? So the options that you'll see are yes, and I am a DevOps engineer. Yes, but my primary role is not DevOps engineering or SRE, or that I don't really care about infrastructure. I'm a developer. So
Fun. This is fun.
answers have coming in. So we have, I think, 5 votes till now. Yeah,
I have the poll open in another window and I can see what other people are voting. It's very exciting.
nice,
Yeah.
cool. So yeah, I'll leave this here as people are joining the stream, and let's see. I'll also enable the second question: is what's the general turnaround time for you in your organization as a cloud infrastructure engineer or as a developer? So minor changes, maybe you want to do some configuration changes, you can get them done very quickly. Or and for major changes, like provisioning completely new infrastructure, a new database, a new network. Yeah, just want to know how much time does it take for people that we have today. Cool. So yeah, people who have joined us, yeah, you can answer those questions. And what I'll do is I'll go to the code examples that we have today.
Super cool.
Or maybe I'll just share what I can see.
We have some people sharing their experience. We have M who would like to switch to ops,
Mm-hmm.
which is cool. I love ops. And then the Santosh would wishes there was an option for freshers, just someone who's interested in the field.
Very cool.
Cool.
So yeah, we do have some votes right now. So I see that we have a good distribution. We have a few DevOps engineers, someone who works on cloud infrastructure but are not really in that particular role, DevOps, SRE, etc., and a few who are developer but interested in cloud infrastructure and how do you provision that. And the turnaround time, I did suspect that a minor change, this section, which is basically any change takes a lot of time, would have a lot of votes because um, change is hard, right? So cloud infrastructure change is hard, and because it's an evolving domain, there's some best practices on that you can follow to get maintainable infrastructure as code. But yeah, it's still evolving, and there's a lot of tools as well. So we'll talk about them as well. So yeah, let's start with um, right. So we can start with versioning, right? So this whole session, right, it's going to be around Terraform and what you should do and what you shouldn't do, how you can make how do you organize your code, what are some best practices you should follow, and missteps is basically steps not in the right correct direction. So we'll begin at the very start. Suppose at an organization you don't really have any cloud infrastructure, uh, how would you get started with uh, Terraform? So it's a beginner to intermediate level session. So we won't really cover Terraform syntax. If you are familiar with Terraform syntax, you would relate to the problems that we're going to talk about today, right? So versioning, for example, versioning your code means having a version control system like Git, and a remote server like GitHub, GitLab, Bitbucket, where a team can collaborate on source code, right? It could be an application, and because we're talking about infrastructure as code, it now includes cloud infrastructure as well, collaboration on cloud infrastructure as well. So, when we talk about versioning in Terraform, there's a lot of different things you need to version to make sure that your code is maintainable, and um, other people on your team that are working with that same code are able to make changes to it, make changes to the actual infrastructure that this code corresponds to. So, in this example, we have a sample VPC that we're creating. So if I open, I can go to this directory, which is called zero versioning. So on the left, you'll see different topics that we're going to cover. One of those is versioning.
Cool.
And so if we run Terraform plan, I already have this applied. There's already a VPC created in an AWS account somewhere with this configuration. So
Mm-hmm.
ideally, we should see that there are no changes, right? So if you run Terraform plan, there's no changes. The infrastructure is already there. Because we're talking about versioning, you'll see that we have specified provider versions. So because we're working with Terraform provider, AWS provider, and we're creating a VPC with a module, we have specified a version for the provider as well as the module that we're using. There's also a log file present here, which we'll talk about in a bit. But suppose this infrastructure was provisioned by someone from the team, and they didn't check it into a repository, right? In a shared repository with the team. Um, so the cloud infrastructure would be present, but other team members won't be able to really make any changes to this existing VPC. They would be able to make changes in console, but infrastructure as code, we're trying to avoid that, right? So we want to manage this VPC with this code that we have. So first part of versioning comes as version controlling this source code. right? So as if you can see, this is checked into a repository with some history. Uh, but yeah, this is a demo Git repository, but ideally you should have a Git repository at the very least. Uh, and you should specify a provider version and a version for your module. So we'll look at what happens if you don't specify these things, right? So, and uh, Terraform log file also plays a big role in that. So, for example, what I do here is I'll move the Terraform log file so that Terraform isn't able to find it. And I'll just, so what I've done is I've removed this version, and also I'll remove this, right? So now if I run Terraform plan, it will complain that let's do an init. Right? So because we created these the infrastructure with specific modules and specific provider versions, what's happening now is it picked up uh, a specific Terraform provider version for AWS, which is 550. And when it tried to run Terraform plan, it we see that there are some deprecation notices. For example, this argument is not supported anymore in this provider, right? Um, if I just revert this back, right? So the example that I'm walking through here is, suppose someone else from the team didn't mention the version when they created this infrastructure, and there are now new versions of this module, VPC module, and the provider as well. So what would happen is someone else comes and runs Terraform plan, and they won't be able to. They'll face some issues, right, when they're running Terraform plan. Now, let's do one thing. We'll just revert this back and um, change a very small thing about this, which is use a different AWS region, right? So if you're familiar with AWS and Terraform, what happens is if you don't specify a region anywhere in your Terraform code, it relies on this environment variable, right? AWS region US East 2. So just for clarity's sake, right? The existing VPC is currently present in US West 2. So if I do this and then run Terraform plan again, so I've replaced the versions. If you can see this, right? I've reverted back the change. There are versions present. So now we should be able to run init. Now, right. So we'll need to move back the log files because we did create the infrastructure with the log file, right? So let's run Terraform init again and plan. And we've also changed the default region that we're running this against. So yeah. So Terraform says that there are changes to be made. So it will provision new infrastructure because we've changed the region, right? And because that isn't present in our code, uh, Terraform assumes that you want all of this to be created in a new region, which is US East 2. But we already have the VPC present in a different region. And to solve this issue, what we need to do is use another block, which is called provider block, right? And specify which region we want everything to be provisioned in. So, a rule of thumb that I ask everyone to follow is be explicit in your configuration. Any configuration that you don't specify in your code uh, either would cause issues when you run Terraform plan, or it would ask you to create new infrastructure. Yeah, there can be a multitude of issues that we can get with this. Yes.
It might have defaults that you don't know and don't want, or it might cause errors in and of itself because it's like expecting your version. It
Yeah.
might just be bad because you're not communicating with your coworkers about what you're doing. Yeah, there are a lot of reasons.
Yeah. So if I run plan again after adding this configuration, if I've done this correctly, there should be no changes in the plan output. Yeah. So it goes back to saying that no changes are required. You have your infrastructure properly set up. Good. Yeah. So basically, version your IC. Also, one thing I didn't talk about is state management. So if I just have this infrastructure locally, right, it creates this Terraform TF state file. But you
Mm-hmm.
do want to collaborate on this infrastructure with your teammates. So use remote state and version your code. Be explicit about your configuration. For example, region, versions, and yeah,
So
and
one question I have, or thing, yeah. So we're talking about versioning, but I'm seeing a couple. Like we're talking about the like using certain versions of a certain Terraform module, for example. Like we're choosing versioned things that other companies are supplying, but then
Mhm.
are we also creating a version for this particular version of our infrastructure as code?
we should be doing that. Yes. So
Yeah.
right now it's using a community module, but
Uh
for
huh.
example, in a further use case, we create our own module, and then that needs to be versioned as well. So because if you're
Okay.
using that module in multiple places, you would need to be versioning your internal modules as well.
Excellent. And what's the advantage of versioning your own?
uh, Similar to this thing, right? So for example, this AZs, which is availability zones, used to be called
Mm-hmm.
something else in a previous version, uh, and s- upgrade to a newer version.
Mm-hmm.
One of the few things that happen with new module versions is it starts supporting new things, right?
Mm-hmm.
While being backward compatible. So by using versioning, if you specify a specific version, you can make sure that your code doesn't break, and in turn, your cloud infrastructure doesn't have any unnecessary changes.
Mm-hmm.
So I think, yeah, versioning your
Okay.
own modules is definitely a
If you
must
roll
have.
something out and it breaks, you can always go back to the most immediate version.
You're right. Cool. So yeah, that was about versioning. I'll just if there's any messages, let me know.
Well, M has a question. People who code in Kubernetes, what are they called? So you called yourself a DevOps engineer. Coding in Kubernetes can mean a couple of things, right? It can mean adding the logic behind controllers, which is usually done in Go. And I
Mhm.
think those people are called cloud developers. And
Cloud
then
engineers, cloud
cloud,
developers.
yeah. And then coding in Kubernetes can also be about managing, like designing systems and integrating different tools and managing. And then you're mostly working in YAML. And what is that type of person called?
I think I would call them as DevOps engineers as well because they are working on deploying services, they're maintaining infrastructure, maybe not at cloud. So either you have your Kubernetes cluster in house or you have it
Uh-huh.
in cloud, right? You're still working with cloud, you're still working with adjacent services, uh, but you could have just infrastructure in your Kubernetes cluster. But yeah, I would call them cloud engineers.
Okay. So either way, you're a cloud engineer, sounds like. And then we have another question. We have a question about Terraform. How do
Mhm.
we secure the Terraform state files when we're collaborating with other teammates?
So there's a lot of different config options for this. Um, so if we look at this, right? So there's a lot of different options Terraform supports to store your state files, right?
Mm-hmm.
So these are called backends. So you could, based on your cloud provider or your preference as a team, you could either store it in S3, you could store it in a database, you could store it in a Kubernetes cluster, uh, in Azure and console. So there's a lot of different options. One thing about versioning related to state backend is you also want to version your state files, right? So if I
Hmm.
do this, you do want to enable versioning here. So
And then, do we audit state files directly?
no, so you could do that, but there are better ways to audit state files, and not really state files, but auditing changes that have happened to cloud infrastructure. So in most cases, you would be auditing a specific incident. For example, uh, some S3 bucket was made public, right? So you would want to audit the code responsible for that, the team that made that change, and any lapses in that process. So, for example, someone's approval was needed, but that wasn't done. But so in AWS, you would look at CloudTrail logs.
Mm-hmm.
I think there's other. You could set up your own custom notification solutions, but I think CloudTrail is one of the solutions.
So when we're talking about securing the state files, if we're not editing them directly, we're editing them as part of our configuration, our infrastructure as code. That
Mhm.
infrastructure as code, you're going to use a system like Git. And then that's where you control access, like who has access to edit that Git file. And that's
Mhm.
how you would control the access to answer this question, I think, which perhaps you did. And
Mhm.
then we have another question. Is it possible to use Terraform for Minikube on a local machine?
Mm, I think you could do it. Yeah, you can do it, right? So there's a provider for Kubernetes, and Minikube uh, does provide is bundled with an API server. So you could point your Terraform code to your Minikube cluster. Yeah, you would need to use this, I think, Kubernetes provider and provide the necessary configuration here. Right. So
Cool,
Minikube would give you a config file, and you should point it here. You can use
cool.
your code to manage your Minikube resources as well.
And then we have another question. What are the specific files in the Terraform root directory that we need to git ignore in case of having a remote repository, which is going to be public?
Yeah, that's a good question. So,
Mm-hmm.
as a rule of thumb, I ignore these directories and files. So, for example, .terraform, where Terraform manages the downloaded modules and plugins, right? So, you would want to exclude that. TFVars file. So, any these files are sometimes used to specify sensitive information. So you would want to avoid that. You want to avoid state files, any state backup files that are created in the process, any Terraform plans. Yeah, with Terraform, I think these are some files, and you could look at git ignore. That would also give you good examples for Terraform, right? So if you, yeah, this repository has a
Will you
bunch of
zoom in on
other
that,
files.
please?
Yes. So there's
Thank
a
you.
bunch of other files you could take a look at. So for example, override.tf is a concept where you can override your existing variables or resources. So you might also want to override that. But yeah, in general, you would want to exclude these in your git ignore.
Great questions, y'all.
Yeah, nice questions. Cool. Let's move on to the next thing, which is authentication and secrets management. This one is also very primitive if you're just starting out using Terraform for cloud infrastructure. A misstep is basically having a sensitive information directly hard coded in your source code. As this source code would be checked into a repository, uh, so everyone that has access to that Git repository would be able to see that password. So you wouldn't really want that. Uh, you want to avoid checking in any secrets, and that applies to Terraform source code as well. So in this case, a simple change that you would do is use TFRs file. One of the things you could do is use a TFRs file. There are other better ways to do this as well. But yeah, so if I run Terraform LAN here, it would ask me those values, right? So either I can supply them on terminal, or I can have a tf-vars file which is ignored currently, which won't be checked into the repository, and specify the password here. So it, oh right, I'll also need to pass in the file. Right. So it's asking me for a username, which is fine, and it can,
Did it?
yeah, if you ignore the other errors, but yeah.
Cool.
So this is one of the things. Um, Other than this, you would also, so uh, authenticating against your cloud provider also needs some credentials. Um, if we look at a bunch of different ways that you can authenticate against
Mm-hmm.
an AWS provider, if I zoom into this, right, there's a few options you have, right? You can use long-lived credentials, which I'm sort of doing here. Is you specify your access key and secret key right here, uh, but we would want to avoid that, right? So um, even moving this to an environment variable is something we would want to avoid. Using short-lived credentials instead of long-lived credentials is, I think, very important in the journey of cloud infrastructure as code adoption, right? So you would want to move away from using long-lived shared credentials, so basically shared across the team as soon as possible, so that you're able to audit what changes were made by whom and when, right? So for example, I create a new S3 bucket, it leaves a with my own credentials, right? So if I use that, uh, that is better than not knowing what caused a change, right? Um, so in suggestion here would be, instead of doing this, um, either have AWS SSO setup with AWS Identity Center, and that can be configured with Terraform as well. But yeah, we'll leave that out of scope. Either have SSO setup or use role-based access control with specific short-lived credentials that are provided via AWS console. So yeah, I think that covers authentication and secrets. If there's any questions.
We do have a question. Um, how do we handle configuration drift with infrastructure as code? Can I take a moment and explain what configuration drift is for those who don't know? So,
Yes, please.
configuration drift, if you're using Git, for example, to define your desired state, and then your actual state is what's actually running in Terraform, if you configure that using a webhook, then whenever you make changes to Git, that's going to push your changes. But if you make changes directly to Terraform, then Terraform is going to look different than what your Git shows, and that's called configuration drift. And
Yeah.
now you answer the question, please.
Right. So there's a lot. I think there's multiple ways you can do this. One way that I've handled this in past is frequently running Terraform plan in a CI pipeline, and uh, if there's any unexpected changes, send a notification to your team Slack or whatever teams, right? Um, Another way is that there are a bunch of tools we have for this now, because infrastructure as code has become so prevalent. There's a lot of different tools that do this for you, but the same setup can be done in your own CI pipeline, run Terraform plan, and if there's any changes, report it back to the team.
Excellent. Thank you. And we have another question. Is it recommended to copy blocks of code from Terraform documentation or use any AI to write them for the custom infrastructure we want to provision on cloud?
That's a good question. So with right, so you can start with getting your Terraform configuration from Terraform docs. I think that's a good place to start.
Yeah.
Uh, and you definitely need to read the attribute references argument references, documentation to understand what each field does. For example, if we take a look at this, right, the field name is a bit descriptive, but if you want to understand exactly what it's about, what are the different options that are supported here, um, you would have to go through documentation. And I think Terraform registry documentation is one of the best documentation
Nice.
sites available. You could get away with a few things with AI. So, for example, even your editor, right, would help you a bit. But in case of um, because the model or the whatever LLM or plugin that you're using isn't exactly aware about a specific Terraform version, a specific provider version, and the specific resource. Uh, it will try to help you out. It will give you some example, some suggestions, but you can't really rely on that. You would have to run on a Terraform plan, and then you might get an error saying that this field doesn't exist or this configuration isn't supposed to be configured this way. But you can get away with a few things with AI. But yeah, you can't replace reading the documentation or the features that your code editor provides. Yeah, it won't be replacing those things completely, at least not soon. I hope
Excellent.
that answers the question. Right. Another point that I'll like to raise here is with long-lived credentials. Uh, there's a few other things as well, right? If someone leaves the organization, this access key and secret key, because they are shared with everyone who needs to run Terraform plan and apply, will need to replace or rotate these credentials. So yeah, long-lived credentials aren't really useful in that sense. They cause more harm than the ease of use they provide. So yeah, move away to short-lived credentials as soon as possible, and yeah, I think AWS SSO and equivalent uh, options are a good place to start. For example, Azure has managed identity, so using that as yeah, I think that covers how do you do that. So we've covered a few very basic things. We'll talk about module organization guardrails now, right? In case of modules and code organization, right? Right off the bat, there's a very um, accepted way on how do you write a module. So a module is a bunch of code, bunch of Terraform resources put together, and you could reuse it, right? So for example, you would want to create a database module and use it in multiple places. A module is also a good way to capture specific policies that you might have. For example, you always want S3 bucket to be private. You never want to create an S3 bucket that is public. Suppose that is a policy in an organization. You could create a private S3 bucket module and reuse it. And you can then put in guardrails to um, make sure that happens. But yeah, we'll talk about that next. But database, right? So a database module or any module for that sake, there's an uh, widely used folder structure. So uh, you would need you would have an output.tf file for to array keep all of your outputs for that particular module in one place. You would have a variables.tf and you would have main.tf. This works for a smaller module, right? Um, so, for example, if we take a look at this module, we're creating a random password. Uh, we're using that password to create a database instance, and we're storing that password in a secrets manager to be used later, right? Other things that we're doing is we can control the length of the password gets that gets generated using this module. So by default, we want it to be 16, but but you can control it, you can change it wherever you're using this module, and an output to the URL that the user can use, right? So at the usage point for this module, uh, you just need to specify where the path is and what is the password length. You can also choose to ignore this, but yeah, mainly uh, pick a standard. Maybe you can call it output.tf, or you can call it outs.tf, out.tf. Uh, have a s- Having a standard module structure can help the whole team be aligned on that. This is the structure we follow. This is where you will find the output for this module. Also, having some good documentation if it's meant to be used by others. Having some documentation about the module in a README file, right where the module code is, with some good examples. For example, this is a trivial case, but examples would really help if the module is uh, built to support different use cases, right? So in our case, we just want to support different custom password lengths, so we have one variable. But you could have another example here if there's if you want to support special characters per se. In case of VPC S3 buckets, you would have different examples for different use cases. So yeah, having a module structure in place, yeah, and examples, I think that is really helpful.
So you're talking about like having consistency within an organization. Do you
Mhm.
think there's like larger level best practices, like especially in open source,
Mhm.
right? Like when lots of different people from different companies are working on something, is there? How do you know what the maybe default best practice is,
In case
or
of
is there not? Yeah.
Yeah, in case of community modules, right? Another
Mm-hmm.
accepted thing is you would have an examples folder. I think that is also
Ah,
something you can adopt. Have an examples folder with different examples. So instead
love
of
it.
having your examples right here, have it inside here. So it's you can run Terraform plan and apply against that code to see what gets generated, what the Terraform module is doing.
Love it.
Yeah, that's one thing we can do. Other than that, I think this having a README file. So this can be auto-generated, right? I'd like to talk about that as well. So
Oh.
you can use Terraform docs to generate this, right? So it won't generate the examples. You would have to add them in with AI maybe. So yeah, you would need
Mm-hmm.
to add those examples yourself. But for example, which providers are being used in this module? Um, Let me close this. Which resources are being might be created in this module? Inputs and outputs, right? So some boilerplate documentation can be auto-generated. There's tools for that. Um, One is called Terraform Docs. You can look at the documentation and use that. It can generate Markdown. So yeah, that's I think widely
Is
used.
Terraform Docs a CLI that comes with Terraform?
No, you'll have to install it
You add
separately.
it. Okay.
Yeah.
Cool.
Cool. Next, about guardrails, right? So, guardrails are supposed to allow users to work inside a framework, so gives them some freedom uh, while allowing them to maybe creating their own infrastructure, right? So, as we're progressing, we uh, need to get to a point where we can allow user to not make any mistakes, right? So, um, suppose we allow everyone in our organization to create databases now. We have created a module for that, and we don't really want to control how many databases can be provisioned.
Mm-hmm.
But we do have some policy in place that it needs to have backup, um, it needs to have encryption enabled at rest, etc., etc. So there are a few different ways this can be done. Uh, Additionally, you would also want to test security best practices, right? So a few of the things that I've talked about, for example, enabling encryption on a database, or enabling uh, versioning in an S3 bucket, can be automated with static analysis tools, right? So I think, uh, let's look at the example, right? So we have a separate repository here, that's meant to emulate an actual Git repository with some infrastructure, right? So you have a few modules, not really modules, some infrastructure provision. So for example, we have some resources we're provisioning for S3 in GitHub, and we have an S3 backend, right? A bucket to keep our S3 state backend, right? Um, Suppose while writing this, right, we want to, while configuring this S3 bucket, we set up versioning configuration as disabled. But we want to make sure,
Will you
uh,
zoom in on that, please?
yes,
Thanks.
right. So we have different tools available to make sure static analysis can be done on these Terraform files, and we can catch these issues uh, either locally and in CI. So let's talk about CI first, right? Uh, First, I'll just quickly show what tool we're talking about. So, for example, this Trivi, right? You can run Trivi config on your source code, and it will show you different violations or misconfigurations that you've done, right? So, if there's a few present here, but in case um, the change that I just made, right? I disabled version configuration for this bucket. Uh, a tool like Trivi would catch this, um, and then you can also gatekeep, right? So if you don't want any violations to go through, you can have CI pipeline set up. So for example, I have a GitHub repository here, um, infra, where I've set up a CI pipeline, right? So where I'm executing Trivi in CI, and it's happening on a pull request or anything that gets merged to main branch. So um, if you're using GitHub, you can set things up this way to run on specific PRs on commits to main branch, and what that would look like is, right? So yeah, okay, I'm not sure, but yeah, ideally what would happen is you would see the output that you see here in CI, and you would also be able to fail that CI pipeline if there's any high uh, issues that are reported with these tools. Similarly, you can also run these checks locally, right, with pre-commit, right? So pre-commit is, so all of these things, right, are not bundled with Terraform. You do have to install them separately, and there's a bit of configuration, but you can customize them as much as you want. So in case of Trivi, it would catch misconfigurations for Terraform, for Kubernetes, and other platforms as well. There's a lot of different things Trivi supports, uh, and you can run all of these checks locally with pre-commit files, right? So pre-commit is a different tool that can be used locally and in CI to run some pre-configured checks, right? So for example, with pre-commit, uh, what I've configured here is, before I commit anything, Terraform format and Terraform docs uh, should be executed, right? So similarly, what I can do is add a Terraform Trivi plugin, right? Um, there are some pre-commit Terraform configurations present here. There's others available by community that can be used. And how this works is, um, you make some change, right? So for example, I have made some changes in the main.py file. Suppose I want to check them in. So here I've disabled the version configuration for this specific bucket, and I want to allow that change, right? So I've staged that change now, and I want to commit that, right? So what pre-commit does is it's essentially a Git hook that runs before your commits, and it doesn't allow you to commit. It fails in case the hooks that you've configured don't pass, right? So it does say that bucket has. I'm not sure whether it's gone, but yeah, it did catch. Oh, let me see. So this is disabled. Right. So now it could. Yeah. So it does say that this change isn't desirable. You should either enable it. Yeah. There's other documentation available with the issue that it prints out. You can go to that page. You can see possible fixes for the specific misconfiguration, and then you can, after fixing those changes, you can move ahead with um, committing those changes and applying those changes.
Nice.
Yeah, so this was about pre-commit. Um, cool. If there's any questions
There is a
related.
question right now.
Mhm.
Santosh says that the thing is, I'm able to provision resources like VPC, subnets, gateways, etc. But I face difficulty when trying to write Terraform modules for load balancers and auto scaling groups. What can I do to improve?
um, I'm not sure about this. So, um, what specifically might be the issue? For example, load balancers and auto scaling groups, right? Um in auto scaling groups, you would need to provision EC2 instances and other infrastructure. It might be difficult to configure that, but I think in most cases, if you are having difficulty related to this, right, there's a lot of community modules available. You could look at how they are doing it, and if that solves your specific problem. But yeah, if you can talk about what specifically goes wrong when you're trying to create these modules, I can maybe help them.
Is there a good place to find community modules?
Yeah, you should be able to find them in Terraform registry.
Nice.
Right. Yeah. You can take a look at here, partner modules. So modules that are maintained by Hashika partners, or modules that are provided by the cloud providers themselves, right? So, um, for example, Azure, I think Azure team creates a lot of different modules. So there's a module for naming specifically. There's a lot of different modules, uh, but yeah, it still requires a lot of effort to use these modules, and you do lose a bit of control when you're working with these modules, right? So you can't really, if you've already created a lot of infrastructure with these modules, uh, you would have to spend a significant amount of time either contributing to these modules or having a fork of it yourself. But yeah, it's a good starting point. But yeah, you do need to spend some effort maintaining these modules if you're using it at a large scale.
And we have another question. Is it bad practice to create multiple resources with the same resource name? For example, multiple ECRs with a syntax for each.
Depends actually. So if you're referring to these resources that you've created in other resources, um, and that also works with for each. For example, you're creating, maybe I'll take a different example from ECR. You have S3 buckets and you name them 1, 2, 3. Uh, in some cases that might be okay, but if those buckets are meant to be used for very specific use cases, it's better to name them what they're being used for. So for example, I think that applies to ECRs as well. If you're creating multiple repositories, container repositories, uh, you would have different use cases in mind. So it would be better to create those resources individually instead of um, wrapping them in a for each, right? Uh, so some pseudocode, for example, um, what I think Vlad is talking about is, okay, right? So instead of this, if I have for each, right, and I say, or maybe if I have count, right, 3, but I'm creating these easier repositories for a very specific use case. I'm assuming that if I do count or for each, what will happen is I'll have to use count index, right? And then it won't be very clear then which repository is meant to be used for which purpose, but instead having these resources separately. So for example, I'm creating one for dev, right? And suppose this one is for prod. It's better to have it this way. Or if there are other resources, create a module out of it and reuse them. Yeah, I hope that answers the question.
That's great. Thank you. So we're getting close on time. Just a
Hmm.
heads up. But
Yes.
yeah, it looks like you have one more left.
Right.
Refactoring.
Yes. So
Yeah.
refactoring is mainly when you already have a few resources and you don't really. Um, so what's happening is, let me take a look at my notes. Right. So in case of Terraform, right, or IAC in general, uh, refactoring is a bit more difficult than refactoring your source code. Suppose application source code. It's difficult uh, comparatively because uh, the source code for IAC represents actual resources somewhere in the cloud, right? And there's state that needs to be managed for each module, right? So in this example, I'll just close this, right? So in this example, we have a Lambda and an S3 bucket being provisioned in this source file, right? So if we go through this quickly, right? So we have a simple Lambda that serves the configuration file from S3. We have an S3 bucket to store that file, and we have a few other resources to configure that specific S3 bucket. So for example, this one blocks all public access to this S3 bucket. And yeah, that's it, right? A few resources. Um, so if I go to this thing, right, and run,
When it's on the bottom line, I can't see your cursor because it's the names blocking it in the stream. There we go. Thanks.
so if I run this, right, I already have this infrastructure provision. So we do have a Lambda, we have an S3 bucket, and if we go to this specific URL, this is what is being served, right? Some configuration that maybe some application needs to use, right? So there are no changes right now here. Uh, but what we're talking about is um, maybe creating a new module for S3 bucket. So because we always keep on creating a new S3 bucket and we have to reuse that configuration. So in most cases, for example, the organization wants to create only public access, private buckets, right? Block all public access to their S3 buckets. So if we plan to move this into a separate module, you would get changes in your Terraform state, right? So if I let's start with the refactoring. We'll see how the Terraform state uh, would change if we just move these S3 resources in a separate module called private S3, right? So we'll create, as we've talked about, the module structure. We'll create a main.tf file. We'll create a variables.tf file. So for example, we would want to accept the S3 bucket as a variable, right? So if we go here, right? So we have a very simple module setup where we're creating an S3 bucket, we're blocking all public access to that bucket. And now we want to use this module here, right, with our Lambda. So the changes that we would need to do is basically use that module. Sorry, I'll just disable this for now. So editor would help in most cases, but yeah, let's what else? We'll need a bucket name, right? So um, the code won't work directly because we have replaced resources with module. So there are still references here. Uh, so to show that, right, I'll just run Terraform plan. So it will fail. In this case, it's saying that it needs to be initialized. And if we run Terraform plan now, yeah, so it says that there are undeclared resources. So let's update those. Uh, we'll also need to add a new output, right? So because we are using ARN from this bucket, the bucket, uh, the module would need to provide that as an output. So let's add ARN, and value would be this S3. Yes, and then we'll update this. Right, I think there's another reference here. What we can do is use copy, use this, and use that local variable for the bucket name. Okay. Now if we run Terraform plan, yeah, we'll see some changes that Terraform is suggesting. For example, it will destroy a few resources and it will create two new resources to replace those, uh, which is mainly it's deleting the public access block and the bucket itself, right? So one way to get around this is uh, because we don't really want to destroy that bucket. One way is we can do Terraform state move, but there's another way to do this with code itself. because the command line version can become uh, problematic because you're updating state files, right? So you don't really want to do that directly. Uh, Another option that I tend to use a lot is move blocks, right? So uh, yeah, let's. I've just copy pasted a few things here, but yeah, let's see. Uh, I'll update this. Okay, right. So what the move block is supposed to do here is it lets Terraform know that the resource that was previously present at this location has moved into a module at this different location, right? This configuration would help you get a clean plan. Let's see if this works. Right. So previously we saw that two resources were getting destroyed and two were getting created. So because we've added the move blocks, Terraform knows that the resources don't need to be destroyed. They just have moved to somewhere else, right? And you can see that in the logs as well. This helps you avoid a lot of issues with state. So directly changing anything in state with the state move command, instead of that, having this in your source itself uh, helps you avoid managing state files or changing anything in the state directly. So this is a good approach to make sure you don't mess up your state again.
Awesome.
Yeah,
We have one good last question, I think.
Mhm.
Can you share a list of some of the good extensions you mostly use while working on Terraform?
The one I think the official one is that I think I use. So this provides syntax highlighting, autocomplete, language server capabilities. It's able to also it's able to format your source code, right? So if you're using VS Code and you use this format option a lot, uh, it works with that. Um, Other thing it can do is suggest different versions, right? So it's I think pretty good for Terraform. Apart from that, I think this there's other tools that I've already mentioned. So Trivi,
Mm-hmm.
Recommit, and
Terraform docs.
Terraform docs. I think those
Yeah.
are the ones that would be a good starting point. And then you can over time uh, add more tools that you find for your specific problems.
Awesome. Did you have some slides you wanted to show to close out?
Yes.
Yeah.
Um, yeah. So right, that's it. There's a few resources listed here to get you started, right? Um, and you can also reach out to me at neeraj@appsheet.com, and also you can reach out at info@appsheet.com.
Those are links that we can't get to.
I'll share a link. Is there a way that we can
If you put it
share?
in the private chat, I can put it in
Got
the
it.
YouTube chat.
Cool. I'll share these links maybe. Yeah.
All right.
Yeah.
So on the YouTube side, we have it. Oh yeah, it's quite a mess if I try to put it up on the screen. Here we go. It's not so bad. You could screenshot that. Um, awesome. Cool. Well, thank you so much for sharing your time and your expertise today.
Thank you,
I'm
everyone.
gonna pull this down and I'm going to, oops, get us back to just us. I appreciate you sharing your time, and thanks everyone for joining today's episode of Cloud Native Live. It is great to have Neeraj Palecha here to teach us about finding infrastructure as code missteps. And I also really loved the interaction and the questions from everyone in chat today. Thank you for being so curious and engaged. I appreciate you. So here in Cloud Native Live, we bring you the latest in cloud native tools and code on Tuesdays and Wednesdays at noon US Eastern. Thanks for watching today. Thanks for those who watched the recording, and have a wonderful rest of your day. Bye.